Welcome to Ask and Learn.
We are given a differential equation and a point in the plane, and we are asked to find the slope field of this equation and the solution which contains this point. To find the slope field, first a differential equation is y prime equals 1 minus xy. So, for a given value of y prime, say y prime is equal to c for some c in the real numbers, this will be equal to 1 minus xy, so that xy is equal to 1 minus c, or that y is equal to 1 minus c over x. And we see that this is the reciprocal function 1 over x, but either stretched or compressed by a factor of 1 minus c. Graph the slope field. Draw the x and y axes. I'll make the scales in them slightly different so that more information can be represented. And we see that along the curve y equals 1 over x, we have c is equal to 0, so that slopes of these tangents are all going to be 0, or they will be flat. So, in particular, at the point 1, 1, you'll have flat segment. At the point 1/2, 2, another flat segment, and so on. And in between all of these, on this curve, you will have flat segments. These go out to infinity, and they approach an asymptote on the left. We'll also have a flat segment at -1, -1, as well as -1/2, -2, and so on, all the way out to infinity. Now, if c is equal to +1, so that the slopes of the tangents are going to be 1, well, this only occurs along the line y equals 0. So the x-axis, where we have that every point is going to have a tangent with slope 1. It's a little bit hard to represent in this graph. Remember that the units are not the same on the x and y axis. So slope of 1 is going to look a little bit flat. c is equal to -1, you see that this corresponds to all the points on the curve y equals 2 over x, which is curve y equals 1 over x stretched by a factor of 2. So, in particular, at point 1, 2, we'll have a slope of -1. It looks flatter than usual again. Likewise, at the point 0.5, 4, have another point slope -1, and so on. Likewise, at the point -1, -2, have a slope of -1. Point -0.5, -4, another slope of -1. You can see that as these hyperbolas get farther and farther away from the axes from the origin, that on the right, the slopes are going to get more and more negative. So this will get steeper and steeper. And this is just an approximation, not the exact slope field, but it sort of gives us a good idea of what's going on. Likewise, as we get further away from the origin, in the third quadrant, slopes are still getting more and more negative. So we have a rough idea of what it looks like for the points in quadrants 1 and 3. Now, some points that we're missing in those quadrants are points like 0.5, 1. If we have a point like 0.5, 1, we plug it into our equation, you get that y prime is equal to 1 minus 0.5 or 0.5. So if we consider that the slope is going to be 0.5, means that it's not as steep as the slope on the x-axis, but certainly steeper than the flat tangents. So we'll see that we have more. We take c equal to 0.5. This is the same as y equals 0.5 over x. This is another hyperbola, but it's going to be pressed by a factor of 2 now. So closer to the origin. And again, this is a rough idea of how it's supposed to look, but it will be flatter. Slopes intermediate between that of the x-axis and the other hyperbolas. we're in quadrant 2, and we have that x is less than 0 and y is greater than 0, so negative xy is going to be greater than 0. So we suppose that x is equal to 0, for example. We see that y prime is equal to 1. So all along the vertical axis, we have a slope of 1, kind of like along the x-axis. We have a slope of 1. Now if we have a slope, say, of positive 2, so c is equal to 2, then our hyperbola is y equals negative 1 over x. This is going to be a reflection across the x-axis of y equals 1 over x, and the slope is going to be 2, so quite steep. In particular, at the point 1, negative 1, we'll have steep slope. Likewise, at the point 0.5, negative 2, and so on. And so we see that as we get further and further away from the origin in these two quadrants, the slope is going to get steeper and steeper. And this is just a rough approximation, but the idea that these slopes are getting steeper and steeper as we go on hyperbolas further and further away from the origin. And we have in these sections in between intermediate slopes. So this was a slope of 2, this is going to be a slope between 2 and 1, so it's a little flatter. Likewise for quadrant 2, between 1 and 2 for the slope. So this is a pretty good picture of our slope field. We have sort of this kind of a diamond formed here around the origin. So we have these excuse me, it's a curfew. But you see we have sort of this diamond pattern here where like all the slopes that are close to 0 are contained in this diamond near the origin. And in order to find the curve which contains the point 0, 0, first note the point 0, 0 is on this curve. I'll mark it in green, and we'll try to follow all the tangents as closely as possible with that curve. So in particular, we see as we approach infinity, with x, start to increase a little bit, and then suddenly start decreasing again until we sort of follow the hyperbola 1 over x. we know all the tangents on that section have a slope of 0. Likewise, as we approach negative infinity, we see that first our graph is going to be decreasing in the y direction a little bit, and then starts to increase until it aligns with hyperbola 1 over x again. So we have this sort of sinusoidal shape on its side,